someone confirm please? Yeah. Thank you. Okay. So yesterday we were discussing strategies. Yeah. Good morning. Yeah. Yesterday we were discussing energies. See, today first of all we will discuss complete nuclear energy. Then we can go for other topics. For the next 10 minutes, please listen properly. See, I will draw one thing. Competition for you is that what I am drawing you have to identify. Your answer decides whether I am a good artist or not. What is this? Huh? Atom. So I am a very good artist. Now, see. So if this is an atom, what is this? This is. Oh. I accept it as artist name. Yeah. See, this is nucleus. What are these? Electrons. Okay. What are these? Protons. And one more? Neutrons. Okay, very good. See, now generally, whatever the body we are, or materials, everything is based on, is made up of atoms. Atoms are the basic building block of any molecule. Say for example, we are drinking water. H2O, this is a molecule. Now this is made up of two individual atoms called as hydrogen and oxygen. Hydrogen and oxygen. It accept chestar kada. Now that means for the to become any molecule we require atoms. Can we say that atom is the building block of molecules? Now you had accepted and you had told me that in an atom, this is an atom and I accept this. Now in this atom, we will be at the center of the atom, we will be having a thing called as nucleus, and in that nucleus, we will be having two different subatomic particles. See, since we are calling this whole as atom, dan lopal unde subatomic kanal kada. Right? So we are calling the inside particles as subatomic particles. Since this whole together becomes an atom, the subparticles in this atom are called as subatomic particles. Now tell me, what are the different subatomic particles in this atom? Protons are there. Protons and neutrons together constitute nucleus. Together constitute nucleus. Both of them will be having mass. This proton and neutron together will constitute atomic mass. Happy? Atomic mass. Now the other subatomic particle is electron. Accept chestunar kada. Now which will be having positive ion, which will be is negative? Proton is positive, electron is negative. Now since there is equal number of protons, equal number of electrons, that is stable. if it is unstable, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ హైడ్రోజన్ అయాన్ అండ్ ఆక్సిజన్ అయాన్ రెండు కలిస్తేనే ఇట్ బికమ్స్ H2O. అక్కడ ఏం జరుగుతుంది? ఇన్ దిస్ హైడ్రోజన్, this is a normal atom. If this is normal atom, there won't be any reaction. We have to do something such that this will become an ion, right? This will become an ion and this also will become an ion. Now this means they are unstable. Ion అంటే ఏంటి? నేను పాజిటివ్ ఉన్నాను అంటే నా దగ్గర ఒక ఎక్స్ట్రా పాజిటివ్ ఉంది, ఐ వాంట్ సమ్ నెగిటివ్. ఇక్కడ నెగిటివ్ ఉందంటే ఐ హ్యావ్ సంథింగ్ ఎక్స్ట్రా నెగిటివ్, ఐ వాంట్ వన్ పాజిటివ్, right? So this universe tries to bring together opposite poles, male and female, positive and negative, right? Now this we are calling as a reaction, chemical reaction. Two different chemicals coming together to form a molecule. ఇక్కడ దాకా క్లియర్ కదా? Now so what you had understood, we will be having an atom. Inside that atom we will be having subatomic particles called as proton, neutron, electron. ఇక్కడ దాకా క్లియర్ కదా? Now in your childhood you might have studied about atomic number. See, all this we are discussing because this is backward linkage for our nuclear energy chapter. ఇవన్నీ మీకు బాగా అర్థం అవుతాయి. It will help better understanding of nuclear energy chapter. Okay, atomic number, atomic mass. Okay, now generally tell me the atomic number and atomic mass of hydrogen. H. See, generally you might be knowing, we will be if we have to identify or give the nomenclature for an atom, we will be writing atomic number downside and atomic mass upside. Now what is atomic mass of hydrogen? చెప్పండి. 2. యాక్సెప్ట్ చేస్తారు లేదా? అటామిక్ మాస్ ఆఫ్ హైడ్రోజన్ ఈజ్ 2. నౌ వాట్ ఈస్ దిస్ వన్ యాక్చువల్లీ ఇన్ దిస్ అటామిక్ నెంబర్? హౌ వీ విల్ గెట్ ది అటామిక్ నెంబర్? అదొకే, అసలు ఎందుకు 1 దానికి వచ్చింది? వాట్ ఈస్ దిస్ వన్ యాక్చువల్లీ? సే ఫర్ ఎగ్జాంపుల్ వీఆర్ టెలింగ్ helium 2 4. What is this 2 and what is this 4? ఆ 2 ఏంటి అసలు? ఎలక్ట్రాన్స్ ప్రోటాన్సా? protons, right? Proton number is given as atomic number. Now say for example this proton number is given as atomic number. Now ఇందులోని ఒక ప్రోటాన్ ఉంటుంది కాబట్టి we are calling it as atomic number 1. Here there will be 2 protons, we are calling it as atomic number 2. Now what is this atomic mass? We told that atomic mass will be coming from ఇందులోని from where we will be getting the mass, atomic mass? Nucleus. Nucleus consists of protons and neutrons. So atomic mass, this ఈ 2 అంటే అర్థం ఏంటి అంటే we will be combining protons plus neutrons, right? ఇక్కడ protons plus neutrons are together called as atomic mass. Now this is a nomenclature for any atom. అర్థమైంది కదా? Now you might have studied about a thing called isotope. విన్నారా ఎప్పుడైనా? What is isotope? If you can remember. Anyone from physics? Anyone from chemistry? Max? Engineering? సో ఇది కూడా ఎత్తపోతే బాగోదు అసలు, కావాలని ఎత్తట్లేదు మీరు. గుడ్ బాయ్, రైట్. నౌ సి, so you got the clarity about atomic number and atomic mass. See, this chapter will be completely technical. If last వరకు ఆగకండి, because everything will be linked. If you are unable to understand even a single thing, ask me again in the same అప్పుడు జరుగుతున్నప్పుడు At the same time, ask me the question. Right? If you wait until the last, you may not understand the next concept. Okay. Now, have you understood the atomic number? Atomic mass. So, atomic mass will be the mass of proton and neutron. That means how many protons are there, how many neutrons are there. Now, there is another concept called as isotope. Right. What is this isotope? We had identified that if proton number is same, adantha hydrogen. Now, but if here the atomic mass will be changing, the change in the atomic mass is because of ikkada proton rendu same kada. So if there is change in the atomic mass, it could be because of neutrons. That means if number of neutrons changes with the same protons, which we will be calling them as isotopes. For example, H12, H13, deuterium. So basically, if mass is being changed because of change in the number of neutrons, we will be calling them as isotopes. Say another example, you might have heard about uranium. What is the atomic number of uranium? Uranium atomic number 20. Reverse cheyandi. 92. Okay, 92 actually. అదేం వైల్డ్ గెస్ అర్థం కాలేదు కానీ నాకు. బట్ యురానియమ్స్ అటామిక్ నెంబర్ ఈస్ 92. కింద ఉంటుంది కదా కొంచెం టేబుల్లో యురానియం. హౌ కెన్ యూ ఎక్స్పెక్ట్ ఇట్ టు బి ఇన్ ది స్టార్టింగ్? బట్ ఎనీవే, యురానియం 92. Now here generally we'll be having 238, 233, 235. Right? So 92 is common. The change is because of neutrons. Now, so all these uranium 238, uranium 233, uranium 235 are called as isotopes of uranium. Accept chestar kada. Right. Take your notes. We'll write that first of all. Telada. See, if you follow clearly, your life will be very much easier with respect to nuclear technology. లేదంటే మీరు ఎన్ని కరెంట్ అఫైర్స్ చూసినా ఎన్ని వీడియోస్ చూసినా ఉపయోగం ఉండదు. ఓకే, నౌ ఫస్ట్ కీప్ హెడ్డింగ్ న్యూక్లియర్ టెక్నాలజీ. See, at the outset again I am telling how we had discussed the space technology, how we had discussed defense technology. There is a purpose lying behind it. Space technology, we had the purposes of communication, broadcasting, navigation and all. For the defense, we have the purpose of maintaining the sovereignty, territorial integrity, defense and security of our country. Information and communication technology for better communication, emerging technologies to even upgrade the existing things. Now this nuclear technology has n number of applications. We will discuss them majorly, and the major application which you know is for energy generation. Okay, మనం ఇంకా అక్కడ దాకా వెళ్ళలేదు. We were first trying to solve the basic issue. Now, have you kept the heading nuclear technology? Write atom, hyphen, first point atom, hyphen, basic building block of matter. Full stop. Atoms combined together, different atoms combined together to form, ఏం ఫామ్ అవుతాయి? మాలిక్యూల్స్. రైట్, మాలిక్యూల్స్. ఎగ్జాంపుల్ H2+O గివ్స్ రైస్ టు H2O. మనకు ముందు ఆ నెంబర్లు అవన్నీ అవసరం లేదు, కెమిస్ట్రీ ఎగ్జామ్ రాయట్లే. ఓకే, నౌ ఫస్ట్ పాయింట్ కదా. సెకండ్ పాయింట్, డ్రా దిస్ డయాగ్రామ్. నాలా కాదు, మంచిగా. ఓకే, right? Okay, next second point ఇది రాశారు కదా, under that diagram write subatomic particles in the atom are subatomic particles in the atom are proton, neutron, comma electron, full stop. Proton and neutrons together form nucleus. Okay, right. So in that point only continue. Atomic number of an atom is defined by number of protons. అర్థమైందా? Atomic number of an atom is decided by number of protons. రేష్మా అర్థం కాలేదా? ఈక్వలే కదా, రైట్? Okay, fine. Right, atomic number. Next, right, atomic mass is based on proton plus neutron. Full stop. Example, uranium 92-235, comma helium 24, He24, U 92-235 అంటే 235 మొత్తం రాస్తున్నారండి, రైట్? helium 24, ఓకే, రైట్. నెక్స్ట్ point, third point, right? Isotopes of an atom are those which have same atomic number but different mass. Example, uranium 235, uranium 238, uranium 233. Downside will be having 92 for all. Okay, uranium 235, uranium 233, uranium 238. Okay, fine. This is the basic you need to understand. Isotope anta ardhamaindi kada. Now this I mentioned that this is a stable thing. Now say for example we are trying to hit this atom. See, general ga manaki in any activity which will be performing any chemical reaction, either there will be endothermic reaction or exothermic reaction. Exothermic means energy will be released outside. Endothermic inside ante em jarugutundi, there will be change. For example, cold one becomes hot one becomes cold. That is endothermic reaction. Exothermic means we will be getting heat outside. Now in the same manner, say we are taking uranium 235 and we are doing something to this. Say for example, we are hitting that uranium 235 hitting that with a neutron, ఇంకొక న్యూట్రాన్ మనం చేస్తున్నాం. Now because of that, obviously for example something is coming and hitting me, some reaction will be happening. Similarly we are hitting with us another subatomic particle itself, right? Now when this hits, there will be some exothermic reaction. అంటే ఏం జరుగుతుంది అక్కడ? there will be some release of heat. Only thing మీరు అర్థం చేసుకోవాల్సింది ఏంటి అంటే, when we are hitting some atom specifically, there will be release of heat. Now if we were able to capture that heat and use that heat to heat the water, and or because for the flow of the water, and we had connected over there one turbine, and with that water it is rotating, can this produce electricity? We know that heat can be converted to electricity. ఇది ఎలా అయినా జరగచ్చు, అవునా కదా? Now say for example we had hit this uranium 235 with one neutron. You had accepted yourself that because of this some type of heat will be coming out. Now say for example with that heat, we had along with that heat in the same place where this uranium reaction is going on, we are keeping some fuel or water, and that is being flown through a wind turbine. That wind turbine can turn. When wind turbines will be turning, can electricity be produced? Now this process is called as nuclear energy generation. అంతే కదా? We want to produce energy. Now for production of energy, some type of activity must happen. Now this wind turbine is being rotating. Because of that we are able to produce electrical energy. To turn this wind turbine, we are sending the water. Now that is going, or some gas. Now to produce that gas or that hot water, we want to produce heat. That heat being produced by this reaction. That means nuclear reaction. Why we are calling this nuclear reaction? Because when we will be hitting a neutron, hitting this uranium with this neutron, this will be affecting the nucleus, and that nucleus will be forming into two different nuclei. Uranium కాస్త barium, krypton, different atoms కింద మారుతుంది మళ్ళీ. Now along with that energy will be released. For that energy, remember our idea is not to produce two different atoms. Barium, for example, when we hit uranium 235, we will get barium and krypton. ఇవి మీరు గుర్తుపెట్టుకోవాల్సిన అవసరం లేదు. But along with that, how we are hitting uranium? Using a neutron we are hitting this. Now when we hit this is broken down into barium and krypton. Now along with that the energy store ఉంటుంది కదా energy. You might have heard this, energy cannot be generated, ఇదంతా it can be just transferred అని స్టోర్ అయ్యి ఉన్న ఎనర్జీ మొత్తము వేరే ఫామ్లో రిలీజ్ అవుతుంది. Now already since this is stable, we are having energy. Once this reaction happens, release of heat happens, release of energy happens. Now what we have to do, we have to develop a thing such that we will be able to capture that. Now using that we can heat the water, using that we can rotate the turbine. Now that obviously turns into electricity. This mechanism happens, this mechanism where energy is producing with the initial thing of nucleus, we are calling this as nuclear energy. Now if we are using this nuclear energy in different fields, we will be calling it as nuclear technology. Say for example, we are using this nucleus for energy generation. This is a nuclear technology for nuclear energy. If we are using this for development of nuclear weapons, that is another type of nuclear technology. If we are using this for food irradiation, మనం చూస్తాం food irradiation, that is also another application of nuclear technology. అర్థమవుతుంది కదా. నౌ దిస్ కంప్లీట్ న్యూక్లియర్ ఎనర్జీ ఎరప్టెడ్ ఫ్రమ్ ది ఓన్లీ ఐడియా దట్ ఎగ్జోథర్మిక్ రియాక్షన్ హ్యాపన్స్ హియర్. అంటే ఇలాగ దీనికి తగలడం వల్ల సమ్ టైప్ ఆఫ్ హీట్ ఈస్ బీయింగ్ రిలీజ్డ్. యాక్సెప్టెడ్ ఎవ్రీవన్? రైట్. నౌ టెల్ మీ ద రీజన్ why we are using uranium then. అలాగైతే మన we have many materials, carbon, we have hydrogen, water bold ఎంత ఉంది, we have lot of skin, carbon is there, calcium is there, potassium is there, but why we are using only uranium here? Huh? Okay, ఇంకా చెప్పండి. I am asking, have you understood the question? What we are telling, we are hitting a neutron, hitting this some atom. Don't consider it as uranium. I am telling that I will be hitting an atom. Uranium is an atom, hydrogen is an atom, helium is an atom, barium is an atom, krypton is an atom. I am telling that I will be hitting this atom with a neutron. Because of that, this will be broken into two pieces, and along with that energy will be released. నేను ఎందుకు ఓన్లీ యురేనియమే వాడాలి మరి? బోల్డ్ అని ఉన్నాయి కదా నా దగ్గర. అట్లా ఏం కాదు అంటే ఓకే. చెప్పండి. వన్స్ థింక్. See, the thing which I told you, you also know before. అవునా కదా? ఇక్కడ మనం డిస్కస్ చేసిన ఈ ప్రోటాన్లు న్యూట్రాన్లు ఇలాగ ఒకటి వచ్చి కొడుతుంది. See, and one more thing, I am telling that here energy is stored inside. When I am hitting with a neutron, this is broken into two different pieces. Say I can also do, I am attaching two different hydrogen atoms. It will lead to the formation of one helium. At that time also that is also an exothermic reaction. If energy is getting released, that is called as exothermic reaction. So be it we are making this into two, or we are combining two to form one, there is release of energy. The first case is called as nuclear fission, since we are breaking down. Second case is called as fusion, because we are combining two. My only question is that leave about fusion for some time. For fission ఒకదాన్ని రెండింటి కింద చేశాను. సే హియర్ ఐ హ్యాడ్ డివైడెడ్ యురేనియం 235 ఇంటూ బేరియం అండ్ క్రిప్టాన్. వై ఓన్లీ యురేనియం? సే వన్ మోర్ థింగ్, ఇన్ దట్ ప్లేస్ ఆఫ్ యురేనియం ఐ కెన్ ఆల్సో యూస్ ప్లూటోనియం ఆర్ థోరియం, బట్ వై ఓన్లీ దెమ్? Unstable elements. See, now what is the atomic number of carbon? 6, mass 12, 612, same number of electrons, same number of protons, everything is same. Now there is a lot of stability. There are no free neutrons. There is lot of stability inside that. Now take the case of uranium, plutonium, these are relatively unstable. Now they see, we hadn't manufactured this. Nature, God had created this. అర్థమవుతుంది నేను చెప్పింది? God had created some unstable nuclei. In the creation itself there is unstable nuclei. అర్థమవుతుందా? This unstable we require an unstable nuclei, then only when we will be hitting something. ఇప్పుడు ఫర్ ఎగ్జాంపుల్ జస్ట్ జోక్, you are going and telling some person who is having a breakup, రియాక్ట్ అయిపోతాడు. నార్మల్ పర్సన్ అసలు సింగిల్ పెద్ద ఎఫెక్ట్ లేనాడు, ఏం పట్టించుకోడు. ఆల్రెడీ దేర్ ఈస్ సమ్ ఇన్స్టెబిలిటీ ఓవర్ దేర్. దెన్ ఓన్లీ వెన్ వీఆర్ హిట్టింగ్ ఇట్ దేర్ విల్ బి సమ్ రియాక్షన్, అదర్వైజ్ దేర్ వోంట్ బి ఎనీ అదర్ రియాక్షన్. ఎగ్జాంపుల్ బాగపోతే నవ్వేసి వదిలేయండి చాలు. ఓకే, గాట్ ఇట్ వాట్ ఐఎమ్ టెలింగ్? సో బేసికలీ బికాస్ దేర్ ఈస్ సమ్ ఇన్స్టెబిలిటీ, అన్స్టేబుల్ ఆటమ్, చెప్పడం కరెక్ట్గా చెప్పారు కానీ రివర్స్ చెప్పారు. Unstable atom, we have selected only few type of atoms, right? And now I am telling, is 235 a stable unstable one? 92, 235, 238, 233, but I cannot produce using 238. మరి ఎందుకు? అన్స్టేబుల్ కదా ఇవన్నీ. I am telling that I can produce, see, first of all, using all these things, I can produce nuclear energy. But producing nuclear energy with 235 and 233 is very much easier. ప్రతిదీ హ్యాండ్అవుట్లో ఉంటుంది, కంగారు పడకండి. బట్ 238 is not so easy. What could be the reason? లేదు, అంతవరకు వెళ్ళక్కర్లేదు అన్న. ఫైన్, ఓకే. సి, so the thing you need to accept for me is that exothermic reaction is happening. Because of that exothermic reaction only we are getting this nuclear energy. Third point em rasaru? Isotopes kada. Fourth point, right? In, see, we will be writing lot of things. మీరు హ్యాండ్అవుట్లో రాద్దామంటే అవ్వదు, సపరేట్ పేజ్లోనూ బుక్లోనూ రాయాలి. ఓకే, ఇప్పుడు ఒక లైన్, తర్వాత మళ్ళీ రాస్తామంటున్నాను నేను. ఓకే, ఇన్ ఫ్యూజన్ ఆర్ ఫిజన్, ఇవేంటో మనం చూద్దాం. ఇన్ ఫ్యూజన్ ఆర్ ఫిజన్ ఆఫ్ atomic nucleus comma it produces free neutrons and releases a large amount of energy. In the bracket, this can be termed as exothermic or endothermic? Exothermic reaction. That means the reaction which is happening is an exothermic reaction. Accepted? Exothermic reaction, full stop. This energy which is released can be termed as nuclear energy. Okay, this is first basic thing you need to understand. Next, so what you are able to understand is that because of some property of uranium or plutonium or thorium, they are able to produce the energy when some type of fission is happening. But the same is not applicable with carbon, helium or say some other material, gallium evaina sare. Right, now that is because of instability and మనం డిస్కస్ చేసాం. Now I am telling that even in those atomic nuclei which are unstable, not all the materials are able to do this nuclear energy generation. Now this leads us to a classification called as fissionable, fissile and fertile materials. Keep this heading: fissionable, see all three are different: fissionable, fissile and fertile materials. Okay, write fissionable first. We will write the difference between three. One, fissionable. These are those materials that can ఒకసారి ఏం రాసాను చెప్పండి. These are those fissionable materials. These are those materials that can lead to nuclear fission when we are using high energy fast neutrons. High energy fast neutrons. Example, uranium 238. Uranium 238. Okay, now keep second one fissile. మూడు రాసేయండి, అప్పుడు డిస్కస్ చేద్దాం. Fissile. Fissile materials are like the powerhouses of nuclear energy they can undergo fission when struck by neutrons of any energy. Right, example, uranium 235, plutonium 239, comma uranium 233. Okay na? Right. Next, fertile. Fertile materials are like the raw ingredients that can be transformed into fissile materials bracket లో రాయండి, transformed into fissile materials, in the bracket transmutation, comma, close the bracket and comma, through a process called breeding, full stop. They are not capable of sustaining a chain reaction on their own. They are not capable of sustaining a chain reaction on their own, but can become fissile after capturing neutrons and undergoing nuclear reactions Example, uranium 238 comma thorium 232, right? Keep your pens down. See here, see what we had identified. We had identified that first of all there is requirement of an instability in an atom for the generation of nuclear energy, and even then we had identified that this instability is not sufficient. We can divide these unstable atoms into three different formats: fissionable, fertile and fissile. Now first of all, what are these fissile? Fissile materials are those materials which can lead to nuclear fission, generate nuclear energy when we hit with a neutron. అంటే న్యూక్లియర్ ఎనర్జీకి మనకి సరిపడే మెటీరియల్ ఈస్ కాల్డ్ యాజ్ ఫిసైల్ మెటీరియల్. ఎగ్జాంపుల్ uranium 235. That means if I am just hitting uranium 235, we can produce, that will be broken down into barium and krypton, and energy will be getting, and we can use that energy. That is called as fissile material. Now what is fertile material? That material which cannot be directly used to produce nuclear energy. First of all, that material should be converted into a second material, and then it should go for nuclear energy. For example, uranium 238, we had mentioned this as a fertile material. Fertile material enti, if we are hitting this with a neutron, this cannot generate nuclear energy. That is not possible. But if we are able to turn this into another atom and then we are hitting the neutrons again, then this can produce nuclear energy. These type of materials are called as fertile materials. That means we can turn fertile to fissile and then nuclear energy generation. Fertile materials are those materials which cannot produce the nuclear energy on their own. అర్థమైందా? ఫర్ ఎగ్జాంపుల్ టేక్ ద కేస్ ఆఫ్ 238. ఇక్కడ ఏం జరుగుతుంది? we will hit one neutron. ఇక్కడ హిట్ కాదు మనం చేస్తుంది ఏంటంటే వీఆర్ యాడింగ్ వన్ న్యూట్రాన్ టు ఇట్. వాట్ హ్యాపెన్స్ హియర్? దిస్ ఇఫ్ యూఆర్ యాడింగ్ దిస్ న్యూట్రాన్, దిస్ బికమ్స్ plutonium 239. We had identified plutonium 239 as, చూడండి plutonium 239 ఎక్కడ రాసాం? fissile. uranium 238 as fertile. That means fertile cannot produce nuclear energy, but fertile are those materials which can be changed to fissile. This fertile uranium 238 is changed to fissile plutonium 239. Now this obviously we know this is a fissile material. If we are hitting the neutrons, nuclear energy will be generated. That is the difference between fissile and fertile. Clear? Now we had identified another thing called fissionable. Now what is this fissionable? Fissionable ante we can produce nuclear energy from them. Fissile is a subset of fissionable materials. There are fissionable materials and there is fissile or some subset of this. Now say for example, if fissionable ante for this fissile material, if we are just hitting with a neutron, it could be low energy, it could be a slow neutron, slow moving neutron, reaction will be happening. But if there is any material which can produce nuclear energy, but it must be hit with high energy, fast moving neutron, those are called as fissionable. అర్థమైందా నేను చెప్తుంది? If we will be able to produce the energy only when we are hitting it with a neutron which is high energy and fast moving, that is called as a fissionable material. In that fissionable material, one subtype is fissile material. Fissile materials enti, we can hit with any neutron, whether it is fast or slow parledu, కానీ slowly move చేసినా సరే అది వెళ్తుంది. Okay, now fertile, it cannot produce the nuclear energy directly. This should first turn into fissile, then this should be turned into nuclear energy. Clear kada? That is the difference between fissionable, fissile and fertile. Okay, clear? Next, keep the heading. ఇంకొక రెండు ఇక్కడ రాసేస్తే everything is there in the handout. Rest. Yeah, one thing we had not discussed about breeding and transmutation kada. You had written that. Now this this uranium 238, this fissile material turning, this fertile material turning into fissile material is called as a transmutation, and the complete process is called as breeding. అర్థమైందా? Complete process is termed as breeding. Fertile material turning into fissile is called as transmutation. Now hitting with the neutron, adding the neutron, this complete process is called as breeding. అర్థమైంది కదా difference? See, in number of exams these will be asked directly. Okay, next, keep the side heading, uranium enrichment. See, first of all, if you have to understand this, you need to know about natural uranium. What is meant by natural uranium? దేవుడు పుట్టించింది. Anything is natural means మీరు దేవుడు నమ్మితే దేవుడు, యూనివర్స్ నమ్మితే యూనివర్స్. So if something which we hadn't created, we will be calling it as nature. Now in the nature we had natural uranium. The thing you need to understand here is that this natural uranium which we will be having do not contain same type of uranium. There will be different types of isotopes inside this uranium. There will be, in natural uranium మీరు ఇప్పుడు చెక్ చేస్తే there will be uranium 235, there will be uranium 238. అర్థమవుతుంది కదా? Now tell me, which can be in this uranium 235 and 238, which can be directly used for nuclear energy? 235. But the problem is that in the natural uranium, if say there is 100 units of natural uranium, naturally we will be getting only 0.7% of uranium 235, rest will be uranium 238. అర్థమవుతుందా? Naturally what we will be getting is only 0.7% of uranium 235, rest will be uranium 238. But for our nuclear energy generation we require 235. అవునా కదా? We require uranium 235. otherwise ఏంటి ప్రాబ్లం? uranium 238 కూడా మనం యూజ్ చేయొచ్చు. ప్రాబ్లం ఏంటి? first we have to turn it into fissile, right? Now the process which increases the concentration of uranium 235 is called as nuclear enrichment. The process which will increase the concentration of uranium 235 is called as nuclear enrichment. అర్థమైందా? Now this nuclear enrichment is very important for our energy generation. We require at least, it should be efficient, we require at least 3 to 5% concentration of uranium 235. How much is there here? So obviously we have to increase its concentration. That means we should add, if you take a bucket of uranium, we have to remove uranium 238 or we have to add uranium 235. This process is called as enrichment. అర్థమైంది కదా? Now for our energy generation 3 to 5% is sufficient, but if we have to develop nuclear weapon 90% enrichment is needed. అర్థమైందా? 90% enrichment is needed. Now, recently you might have seen in the news, Israel and USA have together destroyed the nuclear bases of Iran. Natanz and Fordo air bases nuclear air bases they had destroyed. The reason is that they are trying to enrich. They had brought the uranium for nuclear energy generation, but the government, Israel and USA had identified that they are enriching that to 90%. 20% దాటితేనే weapon కోసం weapon grade. Now that means 20% వాళ్ళు దాటిపోయారు. That means they are trying for nuclear weapon. That's why they had destroyed it. అర్థమైందా? Keep side heading nuclear enrichment. Better already? Okay. Nuclear enrichment. సారీ యురేనియం ఎన్రిచ్మెంట్, న్యూక్లియర్ అంటున్నాను నేను. యురేనియం ఎన్రిచ్మెంట్ మీరే కరెక్ట్, నేనే తప్పు. యురేనియం ఎన్రిచ్మెంట్ ఫస్ట్ పాయింట్. Enrichment is a process of increasing the proportion of U-235 isotope in uranium to make it suitable for use in the nuclear reactors or weapons. Full stop. Second point, natural uranium contains 0.7% uranium 235, 0.7% U-235 and 99.3%, ఇది 0.7 అయితే 99.3గా 99.3% U-238. Full stop. Enrichment aims to enhance U-235 concentration from 0.7 to 3 to 5%. ఫర్ ఏం రాసింది చెప్పండి, నేను ఇది మైండ్ నుంచి చెప్తున్నాను. Natural uranium contains 0.7% U-235 and 99.3% U-238. Full stop. Enrichment aims to enhance U-235 concentration from 0.7% to 3 to 5%. Full stop తర్వాత capital letter. Right. To 3 to 5% for standard nuclear reactors. Standard nuclear reactors are up to 20% for specialized reactors. For specialized reactors. Once look here. See, now we will discuss about nuclear reactors. ఇప్పుడు దాకా మనం డిస్కస్ చేయలేదు కాబట్టి ఒకసారి చెప్తున్నాను. When the nuclear energy hitting of neutrons with this uranium-235 and generation of heat and that going into that turbine and all, this complete place is termed as nuclear reactor. అర్థమైందా? ఈ ప్రాసెస్ అంతా ఎక్కడ జరుగుతుందో వీ హ్యాడ్ నేమ్డ్ ఇట్ యాజ్ న్యూక్లియర్ రియాక్టర్. For efficient success of this nuclear reactor, we require minimum of 3 to 5% enriched. That means 3 to 5% enriched అంటే ఏముండాలి? 3 to 5% U235. Because U235 is fissile material, and for some special reactors we require 20%. అర్థమైంది కదా? Full stop. Next. Nuclear weapons need U235 to be enriched to around 90%. అర్థమైందా? To be enriched to around 90%. This is second point రాసింది. Third one, right, fourth point and last point here. See, this is a news also actually. ఇప్పుడు న్యూక్లియర్ enrichment, uranium enrichment. Fourth point, now we told that we have to increase the concentration of isotope of 235. Now అది ఎలా చేస్తామో మనకు తెలియాలి కదా. Now, right, fourth point, isotope separation techniques like gas centrifuges and gaseous diffusion are used for enrichment. Full stop. Centrifugal process is the most commonly used method. Okay na? Right. So you had understood about uranium enrichment. Okay. Now, so what all we had discussed until now? We had started our discussion with basically about atom and subatomic particles. From there we had identified that there will be atomic number, atomic mass and all, and there we also have isotopes. ఇది చెప్పడానికైనా ఐసోటోప్స్ గురించి చెప్పింది. Now there we had further identified that there will be fissile, fertile and fissionable materials. Now we identified that fissile materials are very much important. For higher concentration of fissile materials we will be doing uranium enrichment. Okay, now open your handouts. మళ్ళీ రావాలి నోట్స్కి కొంచెం. Have you understood until now? See, whatever video you will be watching or whatever material you might have seen, this will be very, very confusing for nuclear tech specific. That's why I am taking time here. Last లో ఉంటుంది. Okay, please.
Concentration of uranium from 0.7 to 3 to 5%. Like concentration అనేది నాకు అర్థం కాదు. అంటే మిగతా 100%లో 0.3% అన్నారు. మిగతా పర్సెంటేజ్ అంతా ఏమవుతుంది?
మిగతా పర్సెంటేజ్ ఇది ఉంది కదా, U238 ఉంది. ఇప్పుడు మనం ఏం చెప్తున్నామనంటే, ఇన్ ది న్యాచురల్ యురానియం మనకి ఈ యురానియం మనకి ఏదైతే బయట మనము మైనింగ్ చేస్తే దొరుకుతుందో ఆ మైనింగ్ చేసే యురానియము జనరల్గా యురానియం 235 కింద న్యాచురల్గా ఉంటుంది, యురానియం 238 కింద న్యాచురల్గా ఉంటుంది. ఈ ఐసోటోప్స్ డిఫరెంట్ ఐసోటోప్స్ అన్నీ కలిపి ఉంటాయి న్యాచురల్గా మనకు దొరికేది. అయితే ఇందులోని ఆ దొరికే యురానియంలోని ఓన్లీ 0.7% 235 ఉంటుంది, 99.3% యురానియం 238 ఉంటుంది. అయితే మనకేం తెలుసు, మనకు ఉపయోగపడాలి అని అంటే వీ రిక్వైర్ 235 మోర్. అందుకు మనం ఏం చేస్తాము, దిస్ ఈజ్ యురానియం 235, దిస్ ఈజ్ యురానియం 238. మనకి కావాల్సింది ఏంటి అంటే వీ హ్యావ్ టు ఇంక్రీజ్ ఈ ఉన్న చిన్న సర్కిల్ మనం పెద్ద సర్కిల్ చేయాలి, 235 పెంచాలి. 235 పెంచాలి అంటే ఏం చేయాలి, 3 to 5%. అయితే ఇది కొంచెం తీసేయాలి, చిన్న గీత పక్కన పెద్ద గీత గీస్తే అర్థం ఉంది కదా. అయితే ఎలా అయినా చేయాలి, లేదు అని అంటే దీన్నైనా పెంచాలి. దీన్ని పెంచాలి అంటే ఐదర్ వీ హ్యావ్ టు యాడ్, వేరే దగ్గర ఉన్న 0.7% ఇంకో దగ్గర ఉంటుంది కదా, వీ హ్యావ్ టు రిమూవ్ ఫ్రమ్ దేర్ అండ్ వీ హ్యావ్ టు యాడ్ హియర్, ఆర్ హియర్ వీ హ్యావ్ టు రిమూవ్ యురానియం 238. అప్పుడైనా దీని కాన్సన్ట్రేషన్ పెరుగుతుంది కదా. నౌ దిస్ కెన్ బి డన్ త్రూ డిఫరెంట్ ప్రాసెసెస్. వీ హ్యాడ్ సీన్ గ్యాసియస్ డిఫ్యూజన్ ఆర్ యూజింగ్ దట్ సెంట్రిఫ్యూజ్. సో ఆ సెంట్రిఫ్యూజ్ ఏం చేస్తుంది అంటే దిస్ విల్ బి సపరేటింగ్ 235 and 238. In another material we will be separating 235 and 238 and we will be taking 235 and adding here. This is called as uranium enrichment. అర్థమైంది ఇప్పుడు చెప్పండి. యా ఓకే. నౌ so the chapter which we are discussing is nuclear technology in the larger energy management chapter. Now major ga see this nuclear technology where we are using the study of nuclei inside the atom had a number of applications in different domains, but the major application is nuclear energy. We will also see different applications in the nuclear technology, nuclear weapons, nuclear energy, food irradiation, in cancer treatment. There are number of applications, but since major activity of nuclear happens for the nuclear energy generation, most of our discussion, 90% of our discussion will be resting with nuclear energy, right? Now yesterday you had seen the share of nuclear energy enta 1.69%. now if you look into the world share, global average is 10%, and some countries like USA even have more than 20%, right? Now what is the benefit of this? వేరే దాంతో కూడా పవర్ జనరేట్ చేయొచ్చు కదా. వాట్ ఈస్ ద బెనిఫిట్ ఆఫ్ వాట్ వీఆర్ టెలింగ్, కరెంట్లీ ది కాన్సన్ట్రేషన్ ఆఫ్ న్యూక్లియర్ ఎనర్జీ ఈజ్ 1.69%. దట్ మీన్స్ ఇఫ్ యూ ఆర్ ప్రొడ్యూసింగ్ 100 units of electricity, in that we are producing only 1.69 units using this uranium process. మనం ఇప్పుడు చూసింది గ్యాస్ వస్తుంది బయటికి, ఎగ్జోథర్మిక్ రియాక్షన్ అంటున్నాం కదా. రెస్ట్ 98% అరౌండ్ వీఆర్ గెటింగ్ ఫ్రమ్ కోల్, సోలార్, విండ్ అండ్ ఆల్. నౌ ఐఎమ్ ఆస్కింగ్ వై వీ హ్యావ్ టు ఫోకస్ ఆన్ దిస్ న్యూక్లియర్ ఎనర్జీ. ఎందుకు ఆలోచించాలి, క్లాస్లో ఇవన్నీ డిస్కస్ చేయాలి? డైరెక్ట్గా థర్మల్ ఒకటే ఉంటే బాగుంటుంది కదా, కోల్ ఒకటే. చెప్పండి. గ్రీన్, ఫస్ట్ ఆఫ్ ఆల్ దెర్ ఈజ్ నో కార్బన్ హియర్. ఎక్కడైనా మనం కార్బన్ తీసుకొని వచ్చామా? ఓన్లీ యురానియం, ప్లూటోనియం, అన్ని పెద్ద పెద్దవి మన రేంజ్. ఓకే, చిన్న చిన్న ఏం లేదు. వీఆర్ హ్యావింగ్ ఓన్లీ బిగ్ యురానియం, ప్లూటోనియం అండ్ ఆల్. పలకడానికి కొంచెం కష్టంగా ఉండాలి. కార్బన్, హైడ్రోజన్ ఆర్ రిలేటివ్లీ ఈజియర్. ఓకే, నౌ సో సిన్స్ carbon or all these which are greenhouse gases are not part of this. This is a highly clean energy. There is no pollution. That's why we are focusing on it, and that's why even our budget and Shanti Act మనం చూద్దాం కరెంట్ అఫైర్స్ లో asks to increase this nuclear energy production. ఎంత మన ఎనర్జీ ప్రొడక్షన్? ఓన్లీ న్యూక్లియర్ 8 gigawatt. We had written 8180 కదా. Actually last month they had launched 700 megawatt additional. Now currently it is 8880. ఓకే, మనం రాద్దాం అండి అక్కడ 8880 That means even though maximum of 9 gigawatt, we had a target of achieving 100 gigawatt by 2047. అవునా కదా? That means without any utility, while will government focus on this? The major utility is that it is highly clean. Okay, of course, since everything in the universe has both good and bad, ప్రతి దానికి కాయిన్కి ఇటుపక్క ఉంటుంది కాబట్టి this also had some bad properties. We will discuss that. Now, will you accept that nuclear energy is important for us? Right, since coal and all can be exhausted easily, ఇక్కడ కూడా exhaust అవుతున్నా సరే relatively it will take a lot amount of time. Okay, now first, so nuclear energy, which we had seen, energy released from the nucleus or core of an atom. Accept చేస్తారుగా, because of that exothermic reaction. Right here, because of exothermic reaction. Yes, Shiva. Right, now this nuclear energy generation, we had told that nuclear energy can be produced. Now the thing is that this nuclear energy can be produced using two different methods. Now the thing which we had discussed until now, uranium enrichment, fissile, fertile, all amounts to nuclear fusion. That is nuclear fission, రెండు విడగొడుతున్నాం కదా. There is another thing also called as nuclear fusion. At that time also there will be exothermic reaction happening and release of energy will be happened. Okay, now so this nuclear energy can be produced in two ways, nuclear fission and nuclear fusion. Underline that, nuclear fission and fusion. Now what happens in this nuclear fission? First we are discussing fission, then fusion. ఫిషన్ అంటే రెండు విడగొట్టడం, రెండింటి కింద విడగొట్టడం. ఓకే, లవర్స్ని విడగొట్టడం. ఇది అక్కడ ఇద్దరిని కలపడం. ఫ్యూజన్లో కలపడం కొంచెం కష్టం కాబట్టి అది ఇంకా మనం అచీవ్ చేయలేదు. యాక్చువల్లీ విడగొట్టడం ఎవరినైనా ఈజీ కాబట్టి వీఆర్ ఇన్ వెరీ హై లెవెల్ విత్ రెస్పెక్ట్ టు ఫిషన్. నౌ దిస్ ఏమైంది? ఓకే, ఫైన్. Nuclear fission. So in this fission what we are doing, we are dividing a couple కాదు, we are dividing an atom, right? We are dividing an atom which is unstable and which is capable of producing nuclear energy. Now here when we will be hitting this with an neutron, nuclear fusion process ఎలా ఉంటుందంటే, we are hitting this uranium 235 with a neutron. What happens with this? Two lighter atoms will be forming. ఇప్పుడు ఈ ఫోన్ ఇరగొడితే ఆబ్వియస్గా కొట్టకూడదు, టూ డిఫరెంట్ పార్ట్స్ ఆర్ ఎన్ని పార్ట్స్ అయినా అవ్వచ్చు కదా. ఇన్ ద సేమ్ మేనర్ దిస్ హ్యాపన్స్, అండ్ అలాంగ్ విత్ దట్ వాట్ వీ హ్యాడ్ ఐడెంటిఫైడ్, energy will be released. Now what we had seen, along with this energy release, if this happens along with the energy, we had also identified that 3 more neutrons are coming for every reaction. Now ఇప్పుడు 3 more neutrons ఉంది, ఇంకా ఇక్కడ uranium 235 ఉంది అని అనుకుందాం, small material. Can this neutron go and hit that uranium 235 again? Can that again break into 2? Again energy will be coming. Now again that will be producing 3 more neutrons. Because of this we are terming it as a chain reaction. అర్థమైందా? Chain reaction. Because the only thing we require for uranium 235 to be broken is one neutron. Neutron ఒకటి కావాలి కదా. Now what we had identified, when we are hitting with this neutron and this is dividing into two lighter elements, along with the energy we are also producing 3 neutrons. Again these 3 neutrons can react with another 235 and again it can break into 2 and again energy will be coming. Again ఇది మళ్ళీ ఇంకొక ఇది స్టాలిన్ ఏంటది? స్టాలినేనా? స్టాలిన్. ఓకే, స్టాలిన్ సినిమా లెక్క అవుతుంది అది. ఓకే, రైట్. అగైన్ 3 న్యూట్రాన్స్ విల్ బి కమింగ్, దిస్ విల్ బి హిట్టింగ్, ఇలా ఇది ఒక పెద్ద ట్రైన్ చైన్ అన్నీ అయిపోతాయి. దట్స్ వై వీఆర్ కాలింగ్ ఇట్ యాజ్ చైన్ రియాక్షన్. ఓకే, నౌ దిస్ ఈస్ ది ప్రాసెస్ ఆఫ్ న్యూక్లియర్ ఫ్యూషన్. రైట్ అ రియాక్షన్ హియర్. అక్కడ రియాక్షన్ ఎక్కడ రాయలేదు నేను. రియాక్షన్ అంటే ఒక ఎగ్జాంపుల్. రైట్, యురేనియం 92 235, యురేనియం 92 235 ఏం చేస్తారంటే దీనికి వచ్చి ఒక బాల్ తగులుతుంది. సమ్ న్యూట్రాన్ ఈజ్ హిట్టింగ్ దట్ యురేనియం 235. దిస్ ప్రొడ్యూసెస్ barium 56 144 plus krypton, barium 56 144 plus krypton 3689, krypton 3689 plus 3 neutrons 3n plus energy 3n plus energy. మళ్ళీ చెప్పాలా? uranium 92 235. I hope now you know what is this 92, what is 235. When we are hitting this with a neutron, this breaks down into two different parts. This breaking down is called as fission. Now fission అంటున్నాం కదా, when this fission is happening, this uranium 235 is getting converted into barium 144, barium 56 144 and krypton 3689. Along with that we are getting 3 more neutrons and the most important part of energy. That energy we are again using for electricity generation. అదంతా ఎక్కడో మనం చూద్దాం. Have you understood what is this nuclear fission? Right, this is one of the example of nuclear fission. Now what is nuclear fusion? What is this nuclear fusion? See, if you want write one more reaction, uranium 235 రాసాం కదా, ఈ ప్లూటోనియం కూడా రాద్దాం. ప్లేస్ లేదనా? రైట్, plutonium 239, plutonium 239 hits with a neutron, basically అక్కడ న్యూట్రాన్ తగులుతుందని, gives rise to zirconium 103 Zr 103. I am telling only the mass. Zirconium 103 plus xenon 134, Xc 134 plus 3 neutrons plus energy. ఓకేనా? మళ్ళీ చెప్పాలా? హ్యాండ్ అవుట్ లేదా? నిన్న రాలేదా మీరు? ఓకే, మరి స్టార్టింగ్ నేను చెప్పలేదు. ఏమైంది? Written the reaction. So for the fission we had written 2 examples. Basically we had taken 2 fissile materials. What are those fissile materials? Uranium 235, another one is plutonium 239. Okay, now అవి ఎలా రియాక్ట్ అవుతాయి అని చెప్పి మనం రాసాం. These 2 are the examples. Now we are going for nuclear fusion. Now what is this nuclear fission, everyone? Nuclear fusion, what is this nuclear fusion? Now in this fusion 2 smaller nuclei will be coming to form a larger nuclei. Okay, so say for example deuterium and tritium combining to form helium. Deuterium and tritium is combining to form helium. Here we will be getting only 1 neutron but lot more energy, hundreds, not even hundreds, thousands of time more energy than nuclear fission. Either we were unable to capture this even now. There is no functioning nuclear fusion plant in our country and rest of the world also. Because the problem ఏమొస్తుందంటే, since we are producing massive amount of energy, how to handle that అనేది మనకు తెలియట్లేదు. We were unable to capture that heat. ఇప్పుడు మన వచ్చిన హీట్ని క్యాప్చర్ చేయాలి and further we have to maintain the temperature. That is not possible with the current technologies. That's why we are working a lot. India and 6 more countries are together running a thing called as ITER. This year mains lo kuda question vachindi. ITER. Similarly, China is in a very better position. Endunaina better position. China is in a very relatively, China manaku nachakapothe all mancholu kaadani kaadu. Right? China is in a very relatively better position with respect to nuclear fusion also. They had a thing called as artificial sun, east అనే ఒక ప్రాజెక్ట్ని తీసుకొని వచ్చారు, అండ్ దే ఆర్ ఇన్ ది ఫైనల్ స్టేజ్ ఆఫ్ డెవలప్మెంట్ ఆఫ్ దిస్ న్యూక్లియర్ ఫ్యూజన్. అర్థమవుతుందా? రైట్. నౌ వాట్ హ్యాపెన్స్ హియర్, సమ్ 2 small nuclei are coming to form a larger nuclei which will release the energy and a neutron. This energy again will be using the same process, water or turbines, ivanni use chesi will be producing the energy. Clear? Now write the example over there. Deuterium and tritium, H2 plus H3, కింద రెండు ఉన్నాయి. ఓకే, H12 plus H13. These are isotopes of hydrogen. H12, H13 called as deuterium, tritium. Now both of them will combine to form helium. What is the atomic number and mass of helium? Helium 2, 4. Now calculate this. 2 plus 3, 5. Here 4. ఇంకొకటి మిగిలింది కదా. That's why we will be getting only 1 neutron. In the earlier case, if you calculate the atomic numbers over there, we know that chemical reaction must be balanced. Now అక్కడ 3 neutrons వస్తున్నాయి. Here we are getting only 1 neutron. Okay, because here helium 2, 4, 1 neutron will be getting energy. This is also an exothermic reaction. Since there is exothermic reaction, we are getting energy. Okay kada? This is an example of nuclear fusion. Deuterium plus tritium giving rise to helium 2, 4 plus, right, plus 1 neutron plus energy. Okay, this is about fusion. Now one thing you need to understand, this we know that sun is very, 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 very powerful. The reason for the power of sun is that the hydrogens, deuterium, tritium over there is getting converted to helium every second, every millisecond, right? Because of that, a lot of energy is getting erupted from the sun. సన్ అక్కడెక్కడో ఉంటేనే మనం ఇక్కడ నుండి ఎండలు ఫీల్ అవుతున్నాం కదా మనం, రైట్? నౌ కన్సిడర్ ద ఫేస్, మన దగ్గర కాదు, అట్లీస్ట్ సమ్ 1 lakh kilometers నియర్ టు సన్. ఓన్లీ స్కెల్టన్ ఉంటుంది, మనది స్కెల్టన్ కూడా ఉండదు ఆబ్వియస్లీ. నౌ రైట్, సో అండర్లైన్ దిస్, దిస్ ఈస్ ద సేమ్ ప్రాసెస్ దట్ పవర్స్ ది సన్. దిస్ ఈస్ ది సేమ్ ప్రాసెస్ దట్ పవర్స్ ది సన్ and generates enormous amounts of energy. Clear? Nuclear fission ki అర్థమైంది కదా? Okay. See, once if you can look here, in the fusion 2 are getting combined to form a single one. In the fission, one is being formed into 2 different. That is the major difference between fission, fusion. Okay. Next. Now we can identify where these reactions are happening. See, at the outset I am telling nuclear fusion is nowhere in our country. In France we are constructing a project, we are doing research called as ITER. That is basically for nuclear fusion. In India we do not have any running or experimentable plant also. Okay, nuclear fusion plant is not there in our country. Only thing which India has is in France. In that area, in that France project called as ITER, as a handout lo undi mottham anta. right? 7 countries are together constructing that ITER project. We will discuss that while we will be discussing nuclear fusion in detail. Now we are fusion ki అర్థమైంది కదా. Now we are going into our nuclear fusion in detail. Okay, now for nuclear fission we told that we have to hit some fissile material. It can be either uranium 235 or plutonium 239 with 1 neutron. The energy will be getting, and we can use that energy for steam generation, everything, right? Okay kada. Now idantha ekkada jarugutadi? The place where everything happens is called as a nuclear reactor. Nuclear reactor, remember, we are telling about only nuclear fission reactors because in our country only fission happens, there is no fusion in our country. Now nuclear ante vedagotte vallu ekku mandi untarani. Now this nuclear fission reactions, currently on date we are having 25 nuclear reactors in 7 places. అవన్నీ కూడా ఉన్నాయి హ్యాండ్అవుట్లో, నేను రాసేటప్పుడు నేను చెప్తాను, అదే రాయండి. 25 nuclear reactors in 7 different places. All these are very much important actually. అందులో ఏం చదవాలి మనం చూద్దాం. Now first of all, what is this nuclear reactor? What are different types of nuclear reactors and how this nuclear reactor will be functioning? We need to identify that in detail. Now, have anyone had used kettle? Kettle అంటే బూత్లా చూస్తారండి. నార్మల్ kettle, electric kettle. Now what happens in that electric kettle, tell me? అందరికీ తెలుసు. ఓకే, ఓకే చెప్పండి చాలు. చెప్పండి, ఏం కాదు, మీరు ఎప్పుడు మాట్లాడరా. చెప్పండి. హాట్ వాటర్ని హీట్ చేసుకోవచ్చు. అక్కడ మనం యూజ్ చేస్తున్న రా మెటీరియల్ ఏంటి? అక్కడ మనం వాటర్ పెడుతున్నాం. లిసన్ హియర్, సీ ఇన్ ది కెటిల్ వాట్ ఈస్ హ్యాపెనింగ్ ఇన్ ద కెటిల్? We are sending some electrical energy. We are sending some energy, be it electrical or anything. We are sending some energy. In that kettle case, we are sending electrical energy. Now, what that is doing? That is heating the water. That will become hot, and further it will be also releasing the steam. Now, say consider this happens in a very large scale. We are doing such that for heat generation మనం పవర్ పెడుతున్నాం. Here for heat generation what we are doing? We are doing a nuclear reaction. That means this is a reactor. Inside that we are doing some nuclear reactions. We had kept uranium 235, and for that uranium 235 we are adding neutrons. With that this is breaking into 2 different parts. Neutrons ivanni kuda vastunayi. We identified that with this energy is being released. Now ee energy ni manam em chestamanante, inside this reactor we will place some water. Now with this, can this become heat? Now what we will be doing? We will attach this to a steam generator and further to a wind turbine. Because of this will be passing through this mechanism, through the steam generator and to a wind turbine. This can turn this turbine. This will produce electrical energy. So basically మనం ఏదైతే కెటిల్లో చేస్తున్నామో, if we are doing that in the large scale, this is called as a nuclear reactor. అర్థమైందా? This is called as nuclear reactor. But in the kettle case what we are doing? We are giving the power directly. Here what we are doing, for that power, for that energy, we are doing the this nuclear reaction. అర్థమైందా? Now there is a classification how we are having geo orbits, leo orbits, meo orbits. Similarly there is a classification of these nuclear reactors based on the materials we will be using inside this nuclear reactor. అర్థమైందా? Based on the materials we will be using inside this nuclear reactor, we had classified them. Okay, first, so these nuclear reactors are fundamentally large kettles that heat water to generate massive amounts of low carbon electricity. There is no carbon, right? Massive amounts of low carbon electricity. Yeah, as we had seen, a nuclear reactor generates and regulates the release of energy by splitting the atoms of specific elements. This energy released in a nuclear power reactor is used to generate steam using the water, which is then used to generate electricity. Okay. Now, for any nuclear reactor, before going into any nuclear reactor, first of all, we will identify what are the different parts of a nuclear reactor. First major part in any nuclear reactor is the fuel. What is our basic material for nuclear reaction? Fissile material కావాలి కదా మనకి. So examples are uranium 235, plutonium 239. We can use anything of them, but it should be fissile. If you are taking fertile materials, what happens? First we have to do breeding చేయాలి. We have to do transmutation, then it becomes a fissile, then we have to go for nuclear power generation. This is relatively costly, time consuming process. Okay. Now first కావాల్సింది some fuel, next control rods. Now why there is a need of this control rod? See, see this reaction. In this we had identified this 3 neutrons came out. 3 neutrons బయటకు వచ్చాయి కదా. Now again this will be continuing a lot. How can we control that? Now if we are not controlling, this can lot of heat ఉంటే అది పేలిపోద్ది కదా, isn't it? We have, when more amount of reactions happens, more amount of chain reactions happens, what will happen? Lot of heat will be coming. We cannot control that normally. ఒక పాయింట్, ఇప్పుడు ఫర్ ఎగ్జాంపుల్ సే you are using geysers or normal water heaters or solar water heaters. ఒక పాయింట్ వరకే కదా మీరు హాట్ వాటర్ చేయగలరు, అవునా కదా? ఆఫ్టర్ దట్ పాయింట్ ఇట్ విల్ బి వెరీ మచ్ డిఫికల్ట్. సిమిలర్లీ if we are unable to control the reaction, chain reaction, we cannot control this. It can become a blast. Fukushima, Chernobyl, అక్కడ అంతా ఎందుకు జరిగిందంటే because we were unable to control the nuclear reaction. That is the main reason why Indians, majorly in some people, environmental activists and all, oppose nuclear plants in our country. Okay, now if we have to, from your knowledge tell me, if I have to control this nuclear reaction, నేను ఏం చేయొచ్చు? See here, further chain reaction is happening because of neutrons. If we are removing that neutrons, తగ్గించచ్చు కదా. Now to absorb these neutrons, the materials which we will be using is called as control rods. అర్థమైందా? కంట్రోల్ రాడ్స్. సే ఫర్ ఎగ్జాంపుల్ we want more reaction. What we will do? See, first of all, in a nuclear reactor, along with the fuel, we will be placing the control rod. If we want more reactions, we will remove that control rod. If we want less reactions, we can insert that control rod. These control rods can absorb neutrons. అర్థమైందా? Yeah. So that is the utility of control rods. See this. These are control rods. Okay. Next, moderator. Now what is this moderator? See, for example, what we had identified while we had discussed about fissionable materials and fissile materials. What is the major difference? ఫిషనబుల్ కి ఫిషైల్ మెటీరియల్ కి ఒకసారి చూడండి, ఓపెన్ చేయండి. ఫాస్ట్ మూవింగ్ హై ఎనర్జీ న్యూట్రాన్. ఫర్ ఫిషైల్ మెటీరియల్ ఎనీథింగ్ ఈజ్ పాసిబుల్. నౌ సో జనరల్లీ మనం యూస్ చేసే మెటీరియల్ బట్టి మారిపోతుంది. సే we want to increase the speed of the neutron, or we want to reduce the speed, because one thing we have to accept that enrichment is a very difficult process. If you know, ఇండియాలో మనం ఏదో యూస్ చేస్తున్నామో we won't be even enriching it. We will be using the natural uranium directly in all the 25 plants in our country. Now అలా జరుగుతున్నప్పుడు whether we require fast moving neutrons or not. When we are using fast moving neutrons, there is a high chance that some type of accident can happen. ఎందుకంటే ఫాస్ట్ మూవింగ్ ఉంది కదా. Now to control the speed we will be using a moderator. Remember the difference between control rod and moderator. In the control rod we are removing these neutrons. In this moderator we are trying to slow down the neutrons. అర్థమైందా డిఫరెన్స్? In this moderator we are trying to slow down the neutrons. Right. Next, see, slow down చేయడం వల్ల ఇంకొక బెనిఫిట్ కూడా ఉంది. That means the same work which control rod can do, this moderator can also do. How this moderator will be doing? Say for example, here it is the neutron, here it is the another neutron, here is another neutron. Now see, here we are having 3 different neutrons. Here we are having uranium-235 for the reaction, natural uranium for the reaction. Now if it is moving faster, it can hit it directly. Slowగా వెళ్ళింది అనుకోండి, reaction will also be less. It will take some time, so it will be better for us to control properly. Once we cannot control, it will be very problematic. Okay, so that's why we also require moderator along with the control rod. Next, coolant. What is the use of this coolant? Now we identified that we have to capture this heat which is produced. How we will be able to capture this heat? We told by burning, by heating the water. అవునా కదా, by heating the water it can become into steam and it can go outside. Now for that at least we require some material, right? That material here is coolant. What is this coolant? The heat released, the heat released during the fission must be transferred from the reactor core to the turbine and alternator. అవునా కదా, హీట్ ఎక్కడి నుండి బయటికి వెళ్ళాలి. నౌ ఆబ్వియస్లీ దిస్ కెనాట్ గో ఆన్ ఇట్స్ ఓన్. This role is guaranteed by the coolant, the fluid used to remove the heat from the reactor which is generated. We are also calling it as nuclear fuel or coolant. Okay na? ఈ న్యూక్లియర్ ఫ్యూయల్ ఏదైతే ఉందో ఈ ఫ్యూయల్ వల్ల జనరేట్ అయిన ఎనర్జీని క్యాప్చర్ చేయడానికి the material which will be using is called as coolant. That means, say for example, in the earlier reaction which we had seen, along with the 3 neutrons we got energy. We want that energy to be moved to the turbines. How it can move? We will be placing water or some type of coolant in it. Now because of that heat, this water will be turned into steam. Now this steam can go outside and this can turn the turbine. So the fluid which we are using for that is called as coolant, because this is also helping to remove the heat. If that heat stays over there, it can blast. Okay, now that is the utility of coolant. Lastly, steam generator. These are large heat exchangers for transferring heat from one fluid to another. చూడండి, దీనికి అటాచ్ చేసి we'll be having the steam generators, right? We are having coolants everywhere. This coolant, heavy water, can go through this steam generator. It will be further going to outside. Steam can delhi. Here we will be having turbines. This can turn them, finally leading to generation of electricity. Okay, these are the major parts in any nuclear reactor. Now have you understood this? If you are able to understand this, then next part will be very much easier. If you want, again I will tell. See, nuclear fuel, basically the fissile material which we will be using. Control rods to absorb the neutrons, moderator to slow down the neutrons, coolant to capture the heat, steam generator for transferring the heat. Okay, now in the world we are having different types of nuclear reactors. We had identified what are the different parts of a nuclear reactor. Now we are discussing what are different types of reactors. Now indulo major ga enti anante, first we have to discuss about pressurized heavy water reactors. Pressurized heavy water reactors. Now this is the third largest type of reactors in the world. అయితే ఇండియాలో ఉన్నవన్నీ ఇదే. There are even more better reactors called as light water reactors, boiling water reactors and all, but we are using pressurized heavy water reactor. Okay, 11% of the global reactors, nuclear reactors, are these pressurized heavy water reactors. Now what are these? These are majorly, first of all, developed in Canada. Fuel we are using is directly the natural uranium. అర్థమవుతుందా? We are not at all enriching the uranium. Directly we are using 0.7% uranium. అర్థమైందా? Now the thing which I told that India utilizes only pressurized heavy water reactor. See, these are the 25 nuclear power plants. Pressurized, mostly all of them are pressurized heavy water reactors. Pressurized heavy water reactors, except for everything other nuclear power plant in India are pressurized heavy water reactors. That means we are using the uranium without any enrichment. అర్థమైందా? Yeah, now why we are calling this as pressurized heavy water reactor and all? First of all, we had identified 5 parts in any reactor. The parts will be changed in every reactor. First, developed by Canada, we are using the fuel uranium-235, natural uranium, and the moderator. The moderator here we are using is heavy water. That's why we are calling it as pressurized heavy water reactor. Okay, what is the role of moderator? Slow down the reaction. Okay, it slows down the neutrons effectively. Okay, next, coolant. Coolant also we had used is heavy water under pressure. Okay, now the uniqueness of this, or to say somewhat problem with respect to this pressurized heavy water reactor, is that even though it produces more energy per kilogram of mined uranium than other nuclear reactors, మిగతా న్యూక్లియర్ రియాక్టర్స్తో పోలిస్తే it can produce more energy of mined uranium, but the problem is that produces a much larger amount of used fuel per unit output. అంటే ఒక యూనిట్ ఆఫ్ ఎనర్జీని తయారు చేయడానికి చాలా ఫ్యూయల్ని ఇది యూస్ చేస్తుంది. ఐ మీన్ టు సే దేర్ విల్ బి లాట్ ఆఫ్ వేస్టేజ్ యాక్చువల్లీ. ఎందుకు లాట్ ఆఫ్ వేస్టేజ్? enrichment is not the right. For energy generation we require lot amount of uranium-235. Now we are having only uranium 0.7% uranium-235. Now this 0.7% అన్ని మన natural uranium అంతా ఇచ్చేస్తే it will be taking 0.7%. So lot of fuel is required, lot of natural uranium is required. If we are having instead of natural uranium we are using enriched uranium, less fuel is sufficient. Accepted everyone? Yeah, this is about pressurized heavy water reactors. This is the first type. Next, the second type of reactor is light water reactor. Second type of reactor is light water reactor. See, these light water reactors are of 2 types. AC off cheyala, తీసుకోండి, రిమోట్ ఎక్కడ ఉందో, ఇక్కడ అయితే లేదు. Light water reactors. See, when you are, once listen, when you are reading, your comfort is very much important actually. Reading, listening, ఎందుకంటే ఇది బ్రెయిన్ యాక్టివిటీ కదా. Even when you are selecting your study hall which you will be reading, or your room, these surroundings are very much important. ఎందుకంటే this increases our productivity. అంటే 10,000 20,000 కట్టి ఎక్కడ జాయిన్ అవ్వడం కాదు, కానీ we will make sure that there won't be any disturbance for us. Now say for example, if this is మీకు కొంతమంది కూలింగ్ అనిపిస్తే ఆ కూలింగే భరిస్తారా, క్లాస్ ఏమంటారా? ఆర్ ఇన్ యువర్ స్టడీ హాల్స్ సే యువర్ లైట్ ఈజ్ నాట్ సో గుడ్, నౌ హెడ్ఏక్ వస్తుంది దానివల్ల, హెడ్ఏక్ తీసుకుంటారా చదువుతారా? వీ హ్యావ్ ఆప్షన్ ఓవర్ దర్, వీ హ్యావ్ ఆప్షన్ టు మాడిఫై దట్, రైట్? సో దానికి ఏం అడ్జస్ట్ అవ్వద్దు, అడ్జస్ట్ అవ్వాల్సిన దగ్గర అడ్జస్ట్ అవ్వాలి. మనం బాగా చదవడానికి ఏం చేయాలో అవన్నీ చేయొచ్చు. ఓకే, నెక్స్ట్ లైట్ వాటర్ రియాక్టర్స్. ఇన్ దీస్ లైట్ వాటర్ రియాక్టర్స్ there are two types as I had mentioned. First is pressurized water reactor. This is boiling water reactor. Em change undochu? In the pressurized heavy water reactor we had used coolant and moderator as heavy water. Here we will be using normal water. In the boiling water reactor we will be using boiling water. And the difference, there we are using heavy water. First of all, what is meant by heavy water? Normal water is H2O. In the heavy water it is D2O. Instead of hydrogen atoms we will be using isotope of hydrogen, deuterium. That is called as heavy water. That is D2O, not H2O. Okay. Now what is this pressurized water reactor? This is the major nuclear reactor across the world. 70% of nuclear power plants are made up of this pressurized water reactor. India lo matram ledu anukondi. Okay, this is made by USSR and this is also called as VVER. Earlier we had two of these actually, vallu manaki ichindi. Now this is enriched up to 3%. Are you able to understand what is this enrichment now? That means in the pressurized heavy water reactor we are using only 0.7% natural uranium. Here we had enriched this up to 3%, and as the moderator we will be using the ordinary water as both coolant and moderator. Coolant, moderator both are ordinary water. Next comes to boiling water reactor. This is second most popular nuclear reactor across the world. Here what we are using, here also the fuel is enriched uranium up to 3%. While writing about uranium enrichment we had seen that for better energy generation we require 3 to 5% of minimum of 3% undali annam, and some special cases require 20%. That's why all these function based on 3%. Okay, now yeah, so basically here we are using boiling water. Next, fast reactor. Now what is this fast reactor? This is the last classification here. What is this last classification? This is a newer version and India is also developing this prototype actually. This is a versatile and adaptable technology, promises to generate or breed additional fuel. Indulo manam em chestamanante we are using uranium-238 directly. We are using uranium-238 directly. Now is uranium-238, once go to the starting, look whether uranium-238 is fissionable material or not. Fissionable kada adigan nenu. It is fissionable. Now if it is a fissionable material, what is the condition for nuclear energy generation? High energy moving fast న్యూట్రాన్. దీని పేరేంటి, ఈ రియాక్టర్ పేరేంటి? ఫాస్ట్ రియాక్టర్. బేసికల్లీ if we are using directly fissionable material and we are using very fast moving neutrons which is high energy, can we produce energy? అవునా కదా? So in this fast breeder reactor we are doing that. That means with uranium-238 directly we can do, there is no need of enrichment. But the problem is that we cannot control that fastness. India had developed this prototype recently. We will see that in the next class. Fast reactors use uranium-238 in addition to the fissile-235 isotope used in most reactors. Now what we will call as fast breeder reactor, we are calling something as fast reactor. Enduku fast reactor antunam? We are using uranium-238 directly, which can produce nuclear energy if we are using fast neutrons. Now in this fast neutrons there is a special case called as in this fast reactors there is a special case called as fast breeder reactor. Fast breeder reactor. Now what is this fast breeder reactor specifically? If these fast reactors can produce more plutonium than the uranium and the plutonium they consume, initially we will be giving them uranium-238 and some amount of plutonium. Now this gets turned into plutonium-239. If this conversion, when this conversion happens, if final output is getting even more, that type of reactor is called as fast breeder reactor. Basically the quantity of plutonium which we are producing is more than the quantity of uranium and plutonium which has been consumed. మనము 3-stage nuclear power plant India చూసేటప్పుడు then we will discuss about this example, then you can understand this properly. Until then, what is this fast breeder reactor? Output will be more than input. Say if we are giving 5 units of plutonium and uranium, we are getting in return 10 units of plutonium. If we are getting more units than the thing which we are consuming, that is called as fast breeder reactor. Now if we have to maintain the fastness, ఏం చేయాలి మనం? What is the equipment which is slowing down the neutrons? So if we remove moderator first, so that's why in these fast reactors there will be no moderator. Underline that. The fast reactor has no moderator. Okay, it relies solely on the fast neutrons. Yeah. So this is about fast breeder reactors. Now there is one more issue with respect to fast breeder reactor actually. Moderator లేనప్పుడు obviously it will be very much difficult to control the chain reaction. That is fine. Now even more bigger problem is that, see, everything here happens with the case of probability. You might have identified probability అంటే తెలుసు కదా, జరగడానికి ఎంత ఛాన్స్ ఉంది అని చెప్పి. Now when here there is uranium-235 or uranium-238, anything, this is moving very very fast. This can skip this, దీనికి తగలకుండా కూడా వెళ్ళిపోవచ్చు కదా. What I am telling is that when this is moving very faster, say for example here there is uranium-238, when we are slowing it down using the moderators, we can make sure slowing ఎలా చేయొచ్చు అని అంటే such that both of them will get in contact. Now if it is moving very faster, there is a chance that they may not come in the contact, but of course ఇది negligible అయినా సరే ఎలాంటి ఒక ఛాన్స్ ఉందని కూడా చెప్తున్నాను నేను. Right, these are different types of nuclear reactors. First one, pressurized heavy water reactors. Moderator and coolant are heavy water. Then we had seen light water reactors. That means in the heavy water reactors we are using D2O. In the light water reactors we are using light water. That means normal water. One type of light water reactor is boiling water reactor. Another type is pressurized water reactor. We are not using heavy water, normal water we are using. And another type is fast breeder reactor. Here there will be no moderator. Okay, yeah, that is the case. Next, potential of nuclear energy in India. What is the case of nuclear energy in our country? Right, we are looking into the landscape of nuclear energy in our country currently. ఇది ఎప్పుడు నేను ఉంది ఇక్కడ risk. Now what is the potential of nuclear energy in India? For the generation of nuclear energy, what is the requirement? First of all, nuclear reactor okay, దానికి fuel కావాలి కదా. Now do we have these uranium reserves? సి మనం కేజీఎఫ్ సినిమా చూసాం కానీ కేయూఎఫ్ లేదు కదా, రైట్? వీ హ్యావ్ గోల్డ్ రిజర్వ్స్ బట్ నాట్ uranium reserves, right? Now that uranium, even though we are having very much less of uranium, we are having thorium. We are having lot of thorium in our east coast, mostly Tamil Nadu, Kerala, Odisha, some places of Bihar. We are having, and in some places of West Bengal, western coast also, we are having monazite sands. In that monazite sand, from that monazite sand, we can produce thorium. This thorium is fertile or fissile. Rasama manam? This thorium is fertile. Now we have to convert that into fissile, right? So even though we are having very less uranium, we have a lot amount of thorium. That so we had prepared our plan such that we will be able to utilize our thorium reserves. సో మనం ఏం చేస్తామనంటే ఈ థోరియంని ఫర్టైల్ నుండి ఫిజైల్కి మార్చాలి అని అంటే ఏం చేయాలో, ఎలా చేయడానికి అవుతుందో we will make sure that happens. For that, Government of India and mainly Homi Bhabha, a scientist who is expert in this nuclear sector, had given 3-stage nuclear power plan for our country. We can discuss that in tomorrow's class. Okay? Advain Uttam? Okay. Do you want class tomorrow? Okay. So we can, okay, in between, I think varam padtadi actually science and class lo avdaniki. After this we have to after nuclear energy some more topics of energy are left. Then we have to discuss defense current affairs. We had left quantum computing and biotechnology, right? Biotechnology takes 2 to 3 classes and 1 class of universe and particle physics. Okay, so ingoga 6-7 classes padtadi man. Thank you. See, first of all, are you able to understand everything? See, nuclear energy is relatively somewhat technical chapter. Andarku ardhamaindi kada? Okay, thank you.